And we'd now like to switch around the speakers, so if I could ask Klaus and Federico to come to the stage, please. And our third speaker, Dario, is, I think he's planning a different sort of entry. So if you'd like, Dario, if you'd like to come here, you can. But if you prefer to prepare yourself for your presentation, please feel free to move over. Thanks. Okay. Yeah, well, ooh. Okay, ladies and gentlemen, our first speaker in the second session is Federico Dossena, the CEO of Italy's leading EPR scheme, Ecopneus. Federico is going to give us a market update on the Italian tyre recycling sector. So, Federico, please make your way to the microphone.
Thank you very much. Good afternoon to everybody, and thank you for inviting me to this session. What I'm going to do, I guess it will be a sort of connection between what we have heard a few minutes ago from my predecessor speakers.
I will leave this here.
And what is going to happen once the tires really reach the end of their life. So what is going to happen when the tire is going to be recycled. And particularly what we in Italy are doing with the end-of-life tires. Okay, so first of all, let me introduce our new logo. Maybe some of you have known the old Ecopneus logo. Now we have changed it in the perspective of making or giving a stronger message related to the ethics and the legality that our company has always worked with. And of course, the graphic design is also recalling about the circularity of the tires and therefore the circularity of the economy that our recycling activity is leading to. What is the history of Ecopneus? What we have done since the beginning of the existence of the society, the company? Since the beginning, we have collected more than roughly 2.5 million of tons of end-of-life tires, and constantly every year we have exceeded the legal target given by the government. And this is because we, of course, are dealing in a country in which some critical position of the end-of-life tires is facing, and therefore we feel our role is to support and give a hand and help in order to resolve the criticities which are scattered here and there in the country. So we feel our role to be really beside of the industry and trying to solve problems at any level. What we do, in fact, and how we act. Well, the Ecopneus recycling chain is made of 18 collectors, so a logistic structure which is interacting and interfering with 26,000 dealers of tire dealers, so very capillary on the territory. We are present from the Alps down to the minor islands around Sicily and Sardinia. And through 19 treatment centers, we convert the end-of-life tires either in alternative fuels or in material which can be used in other material applications. We all know, we have heard that so far it's difficult to get, Mr. Marangoni was telling, it's difficult to get recycled rubber back in the tire manufacturing, and therefore we have to find new and different applications. As I mentioned, we are scattered all over the territory, so we are really covering geographically the whole country, and through our service provider we are fulfilling the two sectors. 52%, as a matter of fact, is given to the energy recovery, so as alternative fuel, and 48%, luckily, is addressed to other applications. We have also created these brands in order to give an orientation. So Tyre fuel is the material going into the energy recovery. Tyre field and Tyre plus, the compounds which are used to prepare the ground for sports playgrounds or finished products. Let's have quickly a look on this kind of application. So the vast majority of the Tyre fuel goes into the cement industry. There is a connection very solid, very historical between the two industries, and it's a good advantage for the cement industry to take alternative fuel coming from Tyre Recycling, because it is substituting the pet coke, so with a lower environmental impact and with a better calorific power compared to the coal. And in this respect, this kind of relationship continues, unfortunately, with foreigner cement industry, because in Italy we have a clear gap of acceptance of alternative fuel given by the authority, which are a little bit reluctant to give authorization for this kind of usage. On the other side, on the material recovery, there is a lot of well-consolidated usage in the sport fields, particularly in the synthetic turf, in the football fields, but many other surfaces have been developed among the few past years. And particularly I'm referring to playground for tennis and for paddle, which is now the emerging sport, basket, playgrounds for kids. So quite a large variety of sports surfaces in which Ecopneus is always trying to invest and put new possibility, new feature in order to improve the performances and the safety of the players on those surfaces. Please note on the top right corner the sailing application. So we are now exploring the possibility to provide surfaces for all the marine activities, because of course the rubber is providing antiscivolo, scusate, qualcuno mi aiuti con la traduzione dell'antiscivolo. They provide grip, the right grip, even if the surface is wet, and of course the bumping capacity. Other applications are clearly into the urban furniture, so something which goes back to the road application, or the soundproofing. We all know that the rubber characteristics is to absorb and return energy in any kind of form. So even the acoustic energy is well managed through the rubber coming from the end-of-life tires. Another sector that we are really pushing hard in these days is the application in the asphalt. The asphalt are showing how when added with rubber powder, they can extend the life by 3 or 4 times, and particularly the elasticity given to the asphalt helps in reducing the noise when the vehicles are passing over the surface. And so far we have pushed and tested already more than 600 kilometers of road with such kind of asphalts, and they are proven to be absolutely granted in terms of noise reduction, up to 5 decibel of noise reduction, and prolonging the life of the surface by between 3 and 4 times. So the asphalt application is something that we are feeling it's really worth to be explored, invested, and studied. What about the future? What about the next step? And I guess that the next speaker will be much more competent in explaining what we are going to introduce is the chemical recycling. Ecopneus is absolutely beside the study and the application of the chemical recycling because, of course, in the perspective of getting back the raw material the tire is made out of, and therefore putting them again into the hands of the tire manufacturer in order to close the loop and to get really bring back the material into the manufacturing of the new tires, of course looking at the possibility to get them also retreaded several times. So this is a short view of what we are doing, what we are acting in here in Italy. And it's, of course, I'm available for any kind of questions, and if you have time and willingness, come to visit us to our stand in order to go deeper into our matters. And I'm now giving the floor to Klaus for the next part. Thank you very much. Thank you.
I think you were the last, but you're the last. Yeah. Okay, so our next speaker is from Chile, Dario Andreani, who's a Chilean entrepreneur, and he's one of the country's leading retreaders also. Now, Dario also has a company called SustrendLab, which is a pioneering technology company who've just invented a lithium-ion battery made out of end-of-life tyres, which is really quite an innovation. Now, Dario is going to tell us all about it, but first we'd like to introduce you his little baby, who's called T-Phite, and if you look at the red carpet, you'll see him.
Hello, everybody. How are you? Hello, everybody. How are you? Nice to see you here. I'm glad to introduce you T-Phite. T-Phite is my little friend here that is the first electric vehicle that is using batteries made from end-of-life tires. So I'm glad to be here to present you this. I'm Dario Andreani, the co-founder of Sustrend and SustrendLab. I'm one of the inventors of T-Phite. T-Phite is the raw material that is made from end-of-life tires to build batteries. So I want to let you know how we did this and what is this story about. So let me leave T-Phite here and start my presentation. Can you help me, please? I don't want to make a mess here. Yes.
Okay.
So, like I said, my name is Dario Andreani. I'm here to present you what is the problem, which is the size of the problem, and what is the solution we developed in Chile in my laboratory to face this problem and get a solution. Why T-Phite? T-Phite is because it's an acronym in between tire and graphite. So T-Phite. T-Phite is the first graphite made from end-of-life tires on human history. How this story begins? Back in 2014, we started up Sustrend, a consultancy firm environmental consultancy firm that their purpose was to support retreading industry in Chile. So back on those days, we did a methodology that calculates and accounts the carbon reductions of the use of a retreading tire instead of use a new tire. So with that methodology, we knocked the door of the Chilean Environmental Ministry, and they take us to be like a retreading industry into the ERP law in Chile. So for first time in history and the first country over the world, we have inside our ERP law a goal of retreading. After that, in 2017, we start to support the tire recycling industry in Chile. And that was our first approach to the tire recycling industry in Chile, and the first step on pyrolysis plants, and the first step to face this huge problem that is the recovered carbon black. So at the beginning of 2018, we discovered that we could transform recovered carbon black from a Chilean pyrolysis plant into nanomaterials. So on those days, I was here in Europe, in the Tyre, back in 2018, showing the audience how we did it. So at that point, was very amazing to see all the faces, surprises faces, seeing how we did these nanomaterials from this black powder. And at that point of my career, I realized that the problem was worldwide and huge. So at the end of that year, we won the innovation program that give us the resources to start working on a recovered carbon black solution. Having those results, in 2019, we decided to develop and build our first recycling raw materials laboratory in Chile, and we built and started up SustrendLab, a technological area from Sustrend, the consultancy firm. So in 2020, we won the first science startup program that gave us the funds to develop the technology until Tier 6 stage. And in 2021, we developed the first prototype of battery using T-Phite, this great battery graphite made from end-of-life tires. So we developed a 2032 model battery, like a button. Do you know the button batteries? That was used in clocks, in calculators, and those. Okay, we did it in our laboratories, and we tested empowering propeller. So when we realize that the battery works, we get one more step, and we build a battery that is 18650 model battery that is used on computers, scooters, T-Phite, and electric vehicles like Tesla. The only difference in between them is that for T-Phite you need just one battery, in your tools, Buddhist tools, you need 1 or 2 batteries, and in a Tesla car or electrical vehicle you need 7,000 batteries. So this validation in 2022 give us the opportunity to be here with you. So I would like to show you what is the problem. The problem is that each year we are generating 1 billion end-of-life tires that have not where to go. So that means is like 1.4 times the Washington, D.C. area. So from the beginning of this year until now, we already generated almost 400 billion tires. So the problem is huge. So pyrolysis plants, pyrolysis is a technology that transforms the end-of-life tires into steel, into pyrolytic oil, and into carbon black. The problem is that carbon black is no market because they're poor quality, they're poor properties. So the problem is that nobody knows how to do with that because it's no market. So we start to study it in our laboratory, and we develop this technology. We developed this technology that is the first graphitic carbon that can be used to build batteries for electromobility. It's a sustainable alternative for battery market, and it has an excellent conductivity and high performance. You have to think that with 120 PCR tires, we can do a ton of T-Phite, and that ton of T-Phite can make like 14 electro vehicles like Tesla, okay? So this technology is a great opportunity to do circular economy in the automotive industry. Why? Because with our technology, we took this recovered carbon black from the pyrolysis plant and we made it T-Phite. Looks like the same, but it's much, much different, and I will show you why. So with this material T-Phite, we develop ion lithium anode that is placed here. This is a copper, how can I say this? It's a copper paper, okay, with the T-Phite inside. So with this, we build our batteries. These are the 18650 batteries that are used in tools, in computers, in electric vehicles. Inside the battery is the anode with our material, and it's a cathode with lithium. So both make the battery works. The thing is, from this poor material here, carbon black, we develop through a chemical technology a transformation to that battery-grade graphite that you can see on the image there. The good thing is that image is our T-Phite under the microscope. And those rugosities you can see on the image give us much better properties than regular graphite. So, what is the good news? The good news are that T-Phite is much better than regular graphite because we did the same efficiencies and capacities, but we did it with 75% less of emissions. So it's better with the environment. But also, we are doing valorization of up of 80 TBR tires to do electric car. So we did it cheaper, we did it faster, we did it better with the environment, and we did it much better. And I will show you why. Our technology, the current stage is TRL6, which means that it's working. In the first image here, you can see our T-Phite that is under the microscope. Then we transformed to build a battery, and with the battery, this year we start to produce modules of batteries to do testings on electric vehicles, on different devices. So on our testings, in our laboratories, we did this exercise. We established the baseline of the capacity of a battery made with recovered carbon black. So we took the recovered carbon black and we built a battery like this. And we start to test it in our tester, in our laboratory. And we can see there that the capacity of the recovered carbon black is very low. It's under the 100 milliampere hour by grain. So with that baseline, we start to test batteries using commercial graphite. That is the white line there, okay? So the commercial graphite has a technical capacity of 372 milliampere hour by grain. For our surprise, our T-Phite is much better than that. You can see there a small amount of difference in between one material and the other one, but for a battery, it's really, really much. We are having results about 400 milliampere hour by grain. That is much, so much. And the other thing that is amazing that we discover over the testing is that if you look at a regular battery, when you start to charge and discharge, and doing all the cycles, over the time, the capacity starts to go down, 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 down. Finally, you can use it anymore. Instead of that, with T-Phite, what's happening is when the cycles start to go over, the material improves their capacities. So, surprise, our material becomes better than regular graphite. So, recovered carbon black has around 80 milliampere hour by gram, like a capacity. The graphite, commercial graphite, has 372. And T-Phite is having, until now, 400 milliamperes. So it's much, so much. What is the business opportunity here that we see? Since 2018 to 2024, the growth of the graphite market is 60% annual. So that means $92 billion each year. So if you look for 1 million electric vehicle, you need around 3,000 tons of graphite. That today, you can obtain it by two ways. One is the natural one, that is mining a carbon mine to get the graphite. And the second one is to do it in a laboratory in a synthetic way using huge amounts of energy. So this is a very sustainable alternative to supply the battery industry with a much less carbon footprint, with less cost, and much better. Oh. So I want to introduce you my team here. They are a very, very young team. I am the older man here. So these are the guys that are doing all the job. And I'm very, very, very happy and proud of them because they are doing a lot of effort. I thank them a lot because all the commitment they have. And wait a minute. And I want to let you know that this was a long process. Hours of effort, not just from me, but also by this great team. We are committed to understand the tire life cycle like a whole, like the people before me told, and I'm very happy because I start to see the life cycle of the tire like a whole from many years ago when nobody talked about this. And for me, it's very happy and very exciting to hear today big people like Michelin, like Marangoni, like all the big players on this industry talking about circular economy, talking about sustainability, because it's the way. It's the way. We are going that way for many years ago, and see that this is happening today is very, very happy for us, because we really are convicted that that is the way. I never thought when my dad take me to my factory, my retreading factory, to play with tires, that I will be involved in a project like this. We are showing to the world today that science and business can go together in order to make this place a better place for future generations. And we are not going to stop. We are recycling one tire at a time. Thank you for listening.
Okay, so we're now moving on to the final presentation of the evening. We're going to talk this time about pyrolysis, and our speaker is Claus Lamer. He's from the consultancy company Weibold, and he's going to talk to us about the opportunities that exist within the tire pyrolysis sector. Thanks.
So, good afternoon, everybody. So, right here. Klaus, that's me. Five. Presentazione. It must be.
Okay.
So great. Thanks for the opportunity to introduce you. Let's say I want to give you a very high level overview over chemical recycling of end-of-life tires. Sometimes it sounds very trivial and easy, but it's not. That a lot of entrepreneurs learned in the past that it's tough, to produce recovered carbon black. Anyway, I don't want to go too much into details today, and especially not too much into the technical details. Maybe in the beginning, I just give you a short, the disclaimer, please don't copy, and so on. Who is Weibold? Weibold is an international consulting company. We are specialized exclusively on tire recycling and end-of-life tire pyrolysis, so the chemical recycling path. Weibold was founded in 1999 by Robert Weibold. Is headquartered in Vienna in Austria, and we have offices around the world in Argentina, Bahrain, India, Mexico, Morocco, and Spain. So you find us everywhere where you need us. Our clients are basically or mainly recycling and pyrolysis project owners and initiators, of course, operators, investors, banks, technology suppliers, and last but not least, the recycling associations around the world, which whom we are allowed to consult. So the problem is already known. We heard it a couple of times. I want to keep it short. Around 30 million tons of end-of-life tires arise every year worldwide. There's very, very sad news in it is that approximately 10 million tons out of these 30 million tons are practically not known where they are going to. So landfill dumped somewhere in your private stockpile, in the garage, and so on and so on. The European Union is primus inter pares, is very good in recycling and collecting tires. 3.5 million tons of tires are collected every year, are rising every year. Out of this, 90%, at least 90% are collected. And now 50% out of this 3.5 million tons are recycled. There are many paths. Yeah, we don't want to discuss now mechanical recycling, yes or no, versus chemical recycling. I want to point you to the 40% energy, meaning practically that 40% out of these 3.5 million tons arising every year in the European Union is combusted. Yeah? I say it very simple, it's burned. Yeah? It's a so-called waste-to-energy recycling path. Yeah? We could discuss about that very, very long. I don't want to do it now. We only say it's practically a destructive, somehow even though you are producing energy, it's a destructive recovery or recycling path because the resources are gone. Yeah? Once you have energy and then poof, that's finished. Yeah? So therefore, we see as a consulting company, together with most of our clients, by the way, a potential for sustainable recovered material to produce or to recover sustainable recovered material at about 1.5 million tons per year. But how to do that? How we get that back? It was mentioned already a couple of times today. It's chemical recycling. Chemical recycling or pyrolysis is maturing. It was a long way to go until now. It started already the first trials in the 2000, beginning of the 2000s with Chinese technologies and so on. We don't want to discuss that. We are not speaking about the most simplest technology. We are speaking about nowadays about state-of-the-art technology, which is running successfully already in Europe. We will speak about that a little bit later. The most important thing for me, at Weibold, I'm also responsible for writing this Academy article series in our monthly newsletter. I found out that it's of utmost importance that we find a common definition. And thanks to the European Chemical Agency, we have now one. It's pretty simple. Pyrolysis is an irreversible chemical decomposition caused solely by a rise in temperature. We see that on the right side. And most importantly, in an inert atmosphere. What means inert atmosphere? Nothing else than there should not be any oxygen, no air. We need no air. We need a temperature higher than 470, let's say 500 degrees Celsius, and we need time. It's the same like you are baking your cake or baking your something in the oven in the kitchen. Now, it's practically the same reactions are running in there. So we see then on the next slide a little bit more about how the steps are running in the pyrolysis. Let's only look at this definition here. I found it very, very interesting because it's not from us. It's from the European Chemical Agency. It's a European agency. What they say is a rule. Pyrolysis of waste rubber and I just quoted here, and end-of-life tires is a chemical recycling operation by which waste materials, so the end-of-life tires, are reprocessed into chemical products like recovered carbon black and tire-derived pyrolysis oil to become, and that's very important, become input feedstock for chemical plants and other industries. And therefore, chemical recyclers are both On one hand, they are waste managers, and on the other hand, they are manufacturers of new substances in the sense of the circular economy. That's not from me, that's a quote from European Chemical Agency, published in last year only. So let's see in some steps what I am speaking here about. You have this end-of-life tire. Yeah, you cannot retread it, you cannot do anything else, you dump it practically. Yeah, no more use. So the first step in the chemical recycling is you have to reach a status of high quality feedstock, and for that you have to cut the tire, you have to shred it, you have to granulate it. You have practically the first step in any chemical state-of-the-art chemical recycling part is a mechanical recycling. Yeah? You take out the steel as much as possible. Nowadays you make it up to 95, 97%. Take out the steel, you take out the textile fibers, and then you have, you sell them. Yeah? It's recycling, mechanical recycling. The granules is the feedstock for the pyrolysis operation. A pyrolysis plant consists of a reactor, an oven, yeah? A reactor which is heated, nothing else practically. Yeah? So if you heat these granules, yeah, the chemical reaction or the heat is decomposing the long chain molecule in the rubber. Yeah? The organic cut it in more little pieces. And those little pieces are flying like a vapor, an oily vapor. You take them out of the reactor, you condense them, practically you don't do anything else, and you cool it, and you liquefy this gas, this vapor gas, and the result at the end is the so-called tire-derived pyrolysis oil. It's very, very similar to crude oil, yeah, and you can totally mix it with crude oil, but, yeah, and that's the trend, yeah, the trend. It's not a diesel, it's not a substitute for diesel, it's not a substitute for any petrol or fuel in the first row. We will see that it is a substitute for the chemical industry to use it, or to substitute petrol-derived feedstocks. And that's the way how it goes in the circle. We will see that a little later. But the good thing is that not all this vapor, not all this oily gas can be condensed. There remains a part which is not liquefying. It's the so-called permanent pyrolysis gas. And this accounting approximately 10% of the feedstock mass. And this 10%, okay, that you use as a fuel to produce the energy which you need to heat the reactor. And I can tell you in advance, probably you know it already, a state-of-the-art pyrolysis plant or pyrolysis operation is self-energy, self-sufficient in the core process. That's important to know. So, okay, something remains because not everything is decomposable. The second important product stream is the so-called carbon black or recovered carbon black, which is not only consisting of all the carbon blacks which were originally in the tire rubber, yeah, but also the silica. You have in the recovered carbon black, of course, silica, the metal oxides, the additives. They are remaining somewhere because you cannot decompose it, and they are the so-called ash in the ash content in the recovered carbon black. So just a quick look. You know that a tire consists of 50% rubber, synthetic and natural, carbon black, silica, 20% accounting, 10% additives, I mentioned it, and this 20% steel and textile. And again, only a chemical reaction is able to decompose the organic content of a tire. The rubber, synthetic or natural, and taking with him the silica, the carbon black, and the additives. So the result in the output is always in between 40 to 50% pyrolysis oil, 30 to 40% recovered carbon black. Again, here, very often I hear, that's impossible. First you say 20% carbon black is in the original tire, now you are creating 40% recovered carbon black. Hocus pocus, how you are doing that? Of course not. Yeah? Don't forget, the feedstock consists of only 80% of the tire weight. Yeah? So, because we have the steel and the fibers we are putting away mechanically, yeah? Then you have only 80%. And when you take out 30 to 40% carbon black, we call it recovered carbon black, but it consists only of 80% original carbons, plus this 20% additives like silica, zinc oxide, mainly silica and zinc oxide, and some other metal oxide. But these two product streams, they are reprocessed and they are becoming feedstock for the tire and rubber industry. I hear pretty often, oh, you are cooking here rubber and that's not environmentally friendly, and by the way you are heating it, and oh, how bad. Yeah? So I understand this critical question, but at the end they are not really valid. Yeah? There are not a lot of studies until now about the life cycle analysis, only one. I show you here the result. It's made in 2010 from Professor Li in China, and there he was comparing various treatment methods and found out that pyrolysis is the best one, the most environmentally friendly. Why? How can you read that? Everything what is down is positive for the environment, so everything what shows down is positive. Everything what is up, so in the positive area, is negative for the environment. So you have to think it other than in your balance sheet. Yeah? There are, of course, minimal impact, logically, because you are utilizing this gas, this 5 to 10% gas, that like you start an engine, you have this flue gas, that's a fact. But on the other hand, you have exorbitant environmental saving, and especially in regard to the resource saving. So only to make it, you can compare it with the Sustainable Development Goals of the United Nations and so on. It really helps to reduce to enhance the resource efficiency, to make the technology cleaner and environmentally sounding, and so on. So here we can have studies over studies. I think that I don't want to waste your time with that. And huge companies like Michelin, even Ecopneus, Bridgestone, and BASF, and all these, if you look on their websites, nowadays it's pretty easy to find their arguments, and they are all of them are pro this chemical recycling route. So it's very important nowadays to have environmental certification. So you know that end-of-life tires are waste. Yeah? That's a fact. Yeah? So you are handling waste. You are a waste manager. After you process them in a chemical recycling plant, you are manufacturer of a new product, of new chemical substances. Where is the border? And the borderline is defined in the Waste Framework Directive, saying the end of waste status. Yeah, big discussions in Europe, in the Commission about that. Where is the end of waste status? Yeah, and one of the kickers, yeah, to get close to receive an end of waste certificate are the sustainability certificates, and at the end, all the major pyrolysis operator like Reoil just in examples, yeah. Reoil in Poland, New Energy in Hungary, Pyrom in Germany, and Restec in Taiwan and Thailand, and Boulder Industries in the US. They are all certificated already. Let's have a quick look on the trend and opportunities. There's a very high demand for recovered carbon black, and I see already an upcoming competition in between all the possible uses. Yeah, on the one hand, pardon, I didn't have my cigarette, so that's why. No smokers here, that's impossible. There's a very high demand for RCP by the tire manufacturers. Only giving you the example here, the joint support by Bridgestone and Michelin together. That what they want is, they want high capacities in constant quality. We are not speaking about so much about this 20% ash which is in the recovered carbon black. That's already proven. Yeah, you can change the recipes a little bit, and that's okay. Up to 40% you can exchange, or up to 40% in a blend. You can use a high quality recovered carbon black, which always consists of 20% ash. Yeah, you cannot say hocus pocus and go away. It's here, and the silica and the metal oxides are pretty good binded to the carbon in the recovered carbon black. Anyway, they say deliver high quantities. We need high quantities. We need a constant quality. Not the worst, but a constant quality. So that's, and of course some product standards. But they are on the way already with the ASTM T36 Commission for recovered carbon black. So here's, it's going on. On the other hand, the rubber and the carbon black industry has another high demand for recovered carbon black. I mean, recovered carbon black is in fact already long ago, let's say 3, 4, 5 years ago, they reached into the industrial practice. Yeah, I will show you an example a little bit later, and it's proven that you can blend recovered carbon black with virgin carbon black up to 40% share. So there's a not very optimistic forecast for the demand of recovered carbon black globally, issued by Notch Consulting. I mean, Paul Eater is probably the top expert on forecasting carbon black demand and knowing the carbon black market. And he's forecasting that 2025, around 400,000 tons of recovered carbon black demand will be given in the global market, and double of that, so 800,000 tons in 2030. We think it's not very optimistic, yeah, but we are far away, yeah, from reaching 800,000 tons per year in a high and constant quality of carbon black. So still a way to go. Pyrolysis oil is waking up, not because of the fuel demand in general, but because the chemical industry is driving the demand. On first place, BASF, if we are speaking from the European market, BASF is demanding or targeting to buy approximately, only in Europe, approximately 100,000 tons of TDO, also tire-derived oil, per year. Nowadays, there are only 2 examples here because they are publicly known. Yeah, there are others too. New Energy in Hungary is delivering the pyrolysis oil to BASF, and Pyrom in Germany is delivering. But those 2 together, yeah, plus the third one, which we know, let's say 10,000 tons per year, what they can deliver now. And the demand is 100,000 tons. So pretty an opportunity. The Black Cycle project is another demand-driving project. It's Black Cycle, probably heard it already. It is the target to substitute the fossil carbon black feedstock, the dirty, very heavy oil. Yeah, but you have to well it. You have to take it from somewhere. So to substitute that with tire-derived oil. This is an European-wide project funded by the European Union, and it's running very, very positive, very positive. It's under the management, let's say, of Michelin and Orion. Orion is a huge carbon black producer, it's a virgin carbon black producer, and they are taking the oil for the trials from Pyrom in Germany. Their target, let's say, from the Black Cycle project is to take these 1.7 million tons of end-of-life tires away from the energy market and to chemical recycling it to produce this oil, and the result would be 700,000 tons per year, yeah, and they could take it. So there will be also here is some kind of competition coming up, yeah? And the pyrolysis industry is running. Yeah? They are overwhelmed by requests. Yeah? So the trends and driving forces, I think we can go fast over this point because you know them. The consumer awareness about the environmental issues are increasing, therefore we are sitting here. There's an ample supply of waste tires around the world. I think there's no discussion about that. An increasing, so with this consumer awareness combined with an increasing demand for recovered material, and most importantly, there are hundreds of millions of euros or dollars, however you want, coming online for this kind of projects. Yeah? Not only in the European community, maybe driven even by the new taxonomy regulation. You can read some articles on our website about that, and new standards are coming up. The opportunities, and the first sentence is probably the most important one, and my last one. The chemical recycling or pyrolysis in Europe and elsewhere, so even in Taiwan and in the USA, they are proven, they are matured, there are even proven business models, and maybe the most important thing, if somebody invests in a partnership with the Hungarians or with the German pyrolysis plant, then they have guaranteed offtake for the oil and for the recovered carbon black, of course, too. So that means that there's a huge support coming up by the big industry. They are jumping into the game. They jumped already in the game. Michelin is, show you only some example. Continental will jointly supply RCP and CP blacks together with Boulder Industry. Birla Carbon develops together with Circtec the biggest, single largest RCP plant in Europe, 100,000 tons per year. Michelin is known, is invested in Enviro, in the Scandinavian Swedish Scandinavian Enviro System is the company name. It's a Swedish company. BASF, we know already, they are even shareholder in Pyrum in Germany, but they have an off-take contract with New Energy in Hungary. By the way, that was not easy for them. New Energy started in 2005. 2005 is probably the oldest existing pyrolysis plant in Europe. Started in 2005, and BASF made a very in-depth technical due diligence, of course. They succeeded, the same with Pyrum. And, oh, sorry, I am already finished. Here are some more examples. In Austria, non-Semperit is buying already over years from Rio the carbon black. Patagonia buys from, and so on and so on. So we have pages of that. The summary is, so, where is the summary? Here we have. So that everything already said. So nothing new. And I thank you for your patience. Bye-bye. Thank you.
Well, that concludes the Tyre Recycling section of the conference. If anybody has got any questions at all for any of the speakers in any of the sessions today, please feel free to ask them the questions outside in the area out there where we're serving some drinks in a moment. We now need to prepare this room for the Recircle Awards ceremony, which will take place in half an hour. So please stay for that. And please join us for something to drink and something to eat, and we'll see you back in here in half an hour. Many, many thanks for attending today. Thank you.